In this video, we are going to be looking at some different past paper IGCSE examination questions on indices. Let's start with this question, which says simplify 16y to the power of 8 to the power of 3 over 4. Now, if we look back at the last video, which was on fractional indices and negative indices, we remember that when we raise to the power 1 over 4, this means the fourth root of x. So what we're going to do is we're going to split the 3/4 into 3 times 1/4, and we're going to do the 1/4 first. And then we'll raise it to the power of 3. Remember that when we've got the brackets, we're just multiplying them together. So 3 times 1/4 gives you the 3/4. Now we can look at the number and the letter separately, the 16 and y to the power of 8. So I'm doing the fourth root of 16 to start with, which means I'm looking for a number that multiplies by itself 4 times to get 16. So the fourth root of 16 is 2. 2, 4, 8, 16. So I get 2. And now we're going to look at the y to the power of 8, and we're raising that to the power quarter. Remember, when we're in brackets, we multiply the powers. So I'm going to multiply the 8 and the quarter together. 8 times a quarter is 8 divided by 4, which is 2. So we have 2y squared. And that's effectively done the inside bit raised to the power quarter. But we still now got to raise this to the power 3. One of the common mistakes here that students now make is they just write 2y to the power 6. But that's not correct, because the 2 hasn't been raised to the power 3 as well. We need to do 2 to the power 3 and y squared to the power 3. 2 to the power 3 is 8. Y squared to the power 3 would be y to the power 6, because we're multiplying them together. If you're finding any of this challenging, go back, look at the series of videos I've made on the rules of indices. That will help inform this video. In the next question, given that 2 to the power of p times 8 to the power of q is 2 to the power of n, express n in terms of p and q. Well, what do we notice? We notice that 8 is a power of 2. So I'm going to rewrite 8 as 2 to the power 3. That helps because now all the bases are 2, and it means I can use my indices laws. I can't do much with indices laws until I get the bases to be the same. So I have 2 to the power of p times 2 to the power of 3. That's just the 8, but the 8 is raised to the power q, so I'm going to raise that to the power q as well. And that will be 2 to the power n. When we have brackets, we multiply the powers. So I can write 2 to the power of p times 2 to the power of 3q equals 2 to the power n. When we're multiplying, we add. So now I can add the powers on the left-hand side together. 2 to the power of 3q plus p is 2 to the power n. And if you think logically, I'm now raising 2 to the power of something and getting 2 to the power of something. Therefore, these somethings, these powers, must be the same. P plus 3q equals n. And that's what we're looking for. We wanted to express n in terms of p and q, which we've been able to do. Let's have a look at the next question. 3 times 4 to the power of 2k plus 8 equals 24. Now, at the moment, there's not very much we can do with our indices laws, so let's just try and solve it like an equation to start with. I've got times by 3, so let's divide both sides by 3, and that will give me 4 to the 2k plus 8 equals 8. And whilst I can't do anything with indices yet, I notice that 4 and 8 are both powers of 2. So if I change 4 to be 2 squared and 8 to be 2 cubed, that will then allow me to use the indices laws. So 4 is 2 squared. We've still got to now raise that to the power of 2k plus 8, and 8 is 2 cubed. Now I've got brackets. I can multiply out the brackets, the powers. So I have 2 to the power, and I'm going to multiply with the power 2 with the 2k plus 8. So that gives me 4k plus 16 equals 2 to the power of 3. At this stage now, I can just equate the powers just like I did before. So 4k plus 16 equals 3. 4k equals minus 13. And therefore k is minus 13 divided by 4. And that's how you would solve that. We tried to make it an equation as much as we could. We then simplified using indices, and when the base is the same, we can then use our indices laws to go and solve it. One final question. 2 to the power of 1/2 n equals 2 to the power of x over 8 to the power y, express n in terms of x and y. And this looks like a fairly nasty question. But let's use our indices laws like before, and let's try and simplify as much as we can. So to start with, on the left-hand side, I have 2 to the power of half to the power n, so I can multiply the powers. I get 2 to the power of 1/2 n. Or, if you want, 2 to the power of n over 2, it's the same thing. I get 2 to the power of x, and I'm going to change the 8 to the power y to be 2 cubed to the power y, because 8 is 2 cubed, just as we had before. So we have 2 cubed to the power y. And again, I will expand the bracket, so 2 to the power of x over 2 to the power of 3y. And we know that when we're dividing, we subtract the powers, so that just gives me 2 to the power of x minus 3y. Now I have actually the answer. Pretty much I have 2 to the power of n over 2 on the left, and on the right I have 2 to the power of x minus 3y, and therefore n over 2 is x minus 3y. And to get n by itself, I just multiply it by 2, so n is 2x minus 6y. There's just a couple of IGCSE past paper exam questions there on indices. If you'd like to see more, please subscribe and let me know if you need any other specific help.